let's explore how we can practically verify whether any material obeys Ohm's law. Now, before we do that, let's quickly recall what Ohm's law is. Ohm's law says that if you take any material, like let's say windings of a wire, and if we apply a potential difference across the ends of that, so let's say the potential difference across the ends of this wire is V, and because of this a current starts running over here, let's call it current as I, then Ohm's law says that V must equal I times R, where R represents the resistance that the material offers to the flow of charges through that material. And we've talked in detail about this in a previous video. So if you need a refresher, it would be a great idea to go back and watch that video and then come back over here. And so the question is, if I have some material with me, how do I check practically whether this relationship, Ohm's law, whether it really holds true or not? So to do this, we need to first understand a little bit more about this thing called resistance. You see, the resistance is a property of the material and its dimensions, and it's something we'll talk more about in the future. But what's important is that it does not depend on the values of voltage or current. So even if we change these values for any given material, like let's say we have for a given wire, let's say, as we change the values of the voltage or the current, this number shouldn't change. In other words, in this equation, this number is a constant. This is a constant. And so another way to look at this is we could say, if we divide this equation by I, we could say V divided by I should equal R, should be a constant. Should be a constant. So to check whether any material obeys Ohm's law, we need to check whether the ratio of voltage and current through that material, is it a constant? It means if we double the voltage, the current must also get doubled because the ratio should remain the same. If we triple the voltage, the current must also get tripled. That's the basic idea behind Ohm's law. So how do we practically test this? Well, one easy way to do this is by drawing a graph. So what we like to do is we like to plot the values of voltage along the y-axis and the values of current along the horizontal x-axis. So let's say we put some value of voltage. Let's say we put a value of 2 volts as an example. And we measure the current, and let's imagine the current turns out to be 1 ampere. Then we'll plot that point over here in our graph. Now, if Ohm's law is valid, then when I double the voltage, if I double the voltage, let's say I make it 4 volts, then the current must get doubled. All right, the current must get doubled, so 2 amperes. So the next point or another point must lie somewhere here. And similarly, if I triple the voltage, so let's say I triple the voltage, so I make it 6 volts, then the current must also get tripled, 3 amps. And so that point would lie somewhere over here. And what you can notice now is that if you join all these points, they lie on a straight line. They lie on a straight line. And this straight line must pass through the origin, because when the voltage is 0, even the current must be 0. And so to check whether any material obeys Ohm's law, all we need to do is draw a graph of voltage versus current and just check whether that graph is a straight line. If it's a straight line, Ohm's law is valid. If it's not a straight line, Ohm's law is not valid. And so in reality, in practice, when you do an experiment like this, You may not get all the points lying on an exact straight line because there could be experimental errors. There could be errors in taking observation. There could be errors in the instruments and many errors. Because of that, we would like to take lots and lots of trials. But if you find that all the points that you have plotted pretty much lie on a straight line, somewhat like this, then we can conclude, yes, this material does obey Ohm's law. On the other hand, if you find the graph is somewhat like this, then clearly the material does not obey Ohm's law. So this one does obey Ohm's law, but not this one. This one does not obey Ohm's law because it's clearly not a straight line. And another thing we could do is, once we plot a graph, from the graph we can calculate what is the resistance of that material. So for example, over here, to calculate the resistance, notice all we have to do is calculate voltage divided by the current. And so for example, we can do that at this point. So at this point, we could say the voltage is 6 volts and the current over here is 3 amps. This is 3 amps. And so if you divide the two, the voltage divided by the current, we get the resistance. And so the resistance in this example would be 6 divided by 3, that is 2 ohms. And so experimentally, from the graph, we can calculate the resistance just by dividing the voltage with current. And you can do that at any point. We could have done the same thing over here and we would have gotten the same answer. You can pause and check that for yourself. You can do that at any point you want and we'll get the same value for R, just simply because this is a straight line. And lastly, things that obey Ohm's law, we usually call them as ohmic materials or ohmic devices. For example, metals obey Ohm's law, so they are ohmic materials. And things which are made of metal are also ohmic. An example would be filament of a light bulb. They are ohmic devices. On the other hand, things that do not obey Ohm's law, we will call them non-ohmic devices or non-ohmic materials. Non-ohmic. An example of a non-ohmic material would be semiconductors. So anything which is made of semiconductor are non-ohmic devices. An example of that are LED bulbs, which are pretty popular today. LED bulbs do not obey Ohm's law. They are non-ohmic devices. So to quickly summarize what we learned, we found that if the voltage versus current graph for any material is a straight line passing through the origin, then that material obeys Ohm's law, and we call such materials as ohmic materials. And from the graph, if we divide the voltage by the current, we get the resistance of that material. And if it's not a straight line, then we'll call them as non-ohmic devices because that means they do not obey Ohm's law.